audible, sir?
Yes, ma'am, it's audible.
Okay, sir. Thank you, sir. So, good afternoon to ladies and gentlemen. A warm welcome to the national level online workshop on mastering mathematical concept with Python programming. And I'm Sudhira. I will be your host and felicitated throughout this workshop. Before we dive into the exciting world of Python programming for mathematics, let's take a moment to understand the purpose and the agenda of this workshop. The workshop was proudly organized by Indian Mathematical Professors Association and jointly in Infinity Research and Development Institute. The purpose of this workshop is to empower you with skills and knowledge needed to leverage Python programming for various mathematical concepts. We aim to bridge the gap between mathematical theory and practical applications, making mathematics more accessible and enjoyable through the power of Python. Today, the second day session, we will continue our exploration of Python by covering trigonometry, integration, differentiation, discrete analysis, statistics, operation research and analysis. The day two session resource person was Mr. Gnanashekar, professor and associate professor of Ratnam College of Arts and Science, and he is the director of Indian Mathematical Professors Association and one of the board member of Infinity Research and Development. Throughout this workshop, we encourage active participants. Feel free to ask questions, seek clarification, and engage in discussion. We are here to learn together. As a reminder, we have a packed agenda for today. We will have sessions from 2 p.m. to 4 p.m. with short breaks as needed. Get starting, sir. Please carry on the session, sir.
Yeah, yes, ma'am. Thank you. Thank you to all. Is the screen is visible, ma'am?
Dear participants, yesterday so many people have asked the yesterday sessions recordings, but unfortunately we have limited data only. So for that reason only we didn't send the sessions recordings to yesterday. Very sure tomorrow we will send the 2 days sessions, recording sessions and files also. Please be patient for some time. Now we will enter the session and the recording sessions and files will be distributed tomorrow or with the certificates. Thank you. Sir, you can continue, sir.
Yeah, thank you, ma'am. Is it audible, ma'am?
Yes, sir, it's audible, sir.
Okay. Okay. Is the screen is visible?
Yes, sir.
Thank you, ma'am. Yeah, dear participants, thank you for your reasonable listening. And as well as in previous session, I will see many concepts by using the Python programming. So, like um, yeah, thank you. So kindly mute your mic for okay. So thank you for your listening. So in today's session, we will see the many concepts mathematics by using Python programming. So today we are flow with trigonometric function, and as well as we are moving with discrete mathematics, several concepts of discrete mathematics like we'll see
Sir,
what is a logic. Yes, ma'am.
sir, sorry. The voice is not clear, sir.
Okay, ma'am. Yes. Is this clear now?
sir. Now it's clear, sir.
Okay, thank you, ma'am. Okay, so in previous session, we see the many concepts we are seeing the basic components algebraic concepts and the calculus part we see in the previous session. Okay, so in day two session, we will see the trigonometric function and as well as the domain of discrete mathematics. We have several topics. So logic and systems, and we have a cryptography, we have a number theory, so we have a graph theory, and we have a uh, real analysis point of view. Okay, so the session will be, we hope the session will be very very helpful for your research and as well as academic. Okay, so kindly we request, so be patient for the session, and um, if you have any queries, kindly ask me. We will try to rectify our queries. Okay, so thank you. In day two session, so first we will say about Python programming for trigonometric function. So as a mathematics field, we know about trigonometric functions like a sine, cos, tan, like that. We have many functions available in the trigonometric concepts. Here, I will see some basic components. Okay, so what is the sine value, what is the cos value, what is the tan value of some we have several identities as well. Okay, so just uh, this is a only one program provided here. So this will be helpful for approaching the trigonometric function with Python programming. Okay, so we don't have time, so that's why we are restrict the only one program for trigonometric functions. Okay, so here, this is a program. So in this program, we are using the two packages like NumPy and as well as Matplot library. Okay, so as of now, already we know the basic construction of the Python programming in yesterday itself. Here we are assign the variables and the radians. Okay, so here we are fixed the angle equal to np dot line space. So 0 comma, this is a value to npi comma 100. Okay, so this is a ranges of the radians. Okay, so that is an angle, and we need to calculate this value of sine, value of cos, and value of tan. Okay, so that's why we have introduced these parameters here: sine values, cosine values, and tangent values. Okay, so next we will plot the sine diagram, cos diagram, and as well as tan diagram. So that is our aim to produce these programs. Okay, so next we will move on to plotting the sine and cos and tan diagram. So okay, so this is a figure size 12,4, and subplot, we will produce the subplot in the Mathematica and MATLAB itself. We know about subplot, the concept. Okay, so this is a subplot of the sine function. So this is a subplot of a cosine function. So this is a coding for subplot for the tangent function. Okay, so this is a just I have run this. It's loading. Yeah. So this is a output for the above coding. Okay, so this is a function from the sine theta, and this is a function of the cosine function, and this is a tangent. Okay, so like that we can produce any trigonometric functions like this codes. Okay, so this is very very easiest concepts. So that's why we are omitting this uh, with this single command. Okay, so we'll have a several agenda in the future slides. Okay, So that's why we are restrict the trigonometric functions in the single command. Okay, so next we move on to the Python programming for discrete mathematics. Okay, so discrete mathematics, one of the huge domain in mathematics. Okay, so here we have a several subjects. So like we have a cryptography, number theory, we have a graph theory, we have a logics and fuzzy logic, and we have a fuzzy logic and systems. Okay, so maximum maximum of the mathematics subjects with under the discrete mathematics. Okay, so just we will see about this discrete mathematics. Okay, so first we will see about the set theory, so basic operations. Okay, so this is a command for creating the set of elements. Here I have created the two sets. A is equal to 1 2 3 4 5. Okay, so this is a syntax for creating a set. Okay, so uh, this is basically from basically we know about Mathematica and MATLAB itself. Okay, so the same template we'll use it in Python also. Okay, so this is creating the two sets. Yeah, here we have created two sets, A and B. Okay, so next we will do this several operations like union of a set, intersection of a set difference, like the concepts I will see in this following comments. Okay, so first we'll need to do the union of two sets. Okay, so this is a command to finding the union of two sets. Okay, so this is a union of yeah, yes ma'am, is there any queries?
You said that cosine sine series will be we can find the value. Similarly, we can use cosecant, cotangent.
Yeah, yes ma'am, yes ma'am, yes ma'am. So the same command already we have provided. This is a subplat for finding the sine function. So if you change this angle as a cosine, so we'll get the cosine function, and we can create the secant as well. We can create some other trigonometric functions. We need to change this value. So here we have put the sine values to provide the sine function. Here we have a cosine values that provide the cosine values. This is a tangent values. Okay, so like that you can put some other trigonometric functions. You will get that plot also, that plots.
Thank you.
Okay, ma'am. Okay, so next we will need to do the union of two sets. Okay, so this is a command to doing the union of two sets. Okay, so this is a union B. Okay, so this is a general command. You can use this symbol as well as union as well. Okay, so like just typing union, you can also get the output. Okay, so the both are same union result, which is equal to A slash B, and the union result is equal to A dot union B. We can use these any one command. Okay, so both two are defined the same values. Okay, so this is a printf value. Just we can get output. So just wait, just I need to run this. Here we can created the set. Just run this, and after that you should run this. Okay. So this is a union of two sets. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is a union of the above two sets. Okay. So next we will need to identify the intersection of the result intersection set. Okay, so here we have a we need to use A and B, or A dot intersection B. Okay, so the same, both are the same similar command. You can use any one. Okay, so the intersection of the sets is a 4 comma 5. So the common values, so here we have a 4 comma 5, and the set B contain the 4 comma 5. So we'll see what is the Python value. Yeah, So Python also produce the value of 4 comma 5. Okay, so the next one is a difference of a sets a minus b or b minus a. Okay, so this is a set difference. Okay, so like already we have defined the set a and b. Here we need to calculate a minus b. Okay, a minus b is this is a basic mathematical operation. Just run this. So this is a minus b 1 comma 2 comma 3. 1 comma 2 comma 3 is a minus b, and same like that we can calculate b minus a as well. Okay, so the next one is the next concept is symmetric difference of the set A and B. Okay, so this is a generic command for the symmetric difference of result A cap B, or we can use this command as well. The symmetric difference result is equal to A dot symmetric underscore difference. Okay, so just I can copy this. So this will be useful for just right. I'll put this coding in chat box also. If you are doing the hands-on, just try these commands. Yeah, so the next we will see about the symmetric difference of the sets A and B. Okay, so the symmetric difference of set A and B is, so this is the result for A and B. The symmetric difference of A and B is 1, 2, 3, 6, 7, 8. Okay, so this is a symmetric difference of A and B. Okay, so just you can also try these comments. Okay, so the next one is we need to our element is a subset of the particular set. Okay, so we need to identify subset and as well as a power concept. So next we will see about check if A is a subset of B. Okay, so just we'll check. So A is a not subset of B, and as well as B is not subset of A. Okay, so this is a concept. Okay, suppose we can say values of 1, 2, 3, 5, then it will make a subset of subsets concepts. Okay, so the next concept is generate the power set. So power set is, all of you know about the power set. Okay, so this is a coding for generating power set, the particular set. Okay. So we have provide the S set of elements 1 comma 2 comma 3. So there is a result 2 power n. Okay, so 2 power n means we have 8 elements, 8 subset will be available for this given input. Just we will check how many sets will provide. Yeah, 1, 2, 3, 4, 5, 6, 7, 8. Yes. So Python provide 8 power set of the particular set. Just we can change the value 4, 5 as well. Okay. So 1, 2, 3, 4, 5. So just run this. Yeah. So this will provide around 32 elements, 32 subsets. Okay, so like that we can generate the power set as well. Okay, so we can provide any numbers or any sets. Okay, so like we can put any number of elements, 10 as well. Just so this will provide these number of sets. Okay, so the next one is we need to identify what is the length of the particular set. Okay, so here I have provide s is equal to 1, 2, 3, 4. We need to identify what is the length of the given set. Okay, so this is a program for identifying the length of the set. Here we can introduce the power set concepts. Already we know about the power set concepts in the previous programming. here we can run the power set for our identifying the length. Okay, so here I can use the for loop for I is equal to n I in the range of 2 power n. So this is a power set concept. There have a mini subset. We can call that subset as well, and we can identify what is the length of yes. Okay, so just run this. Okay, so this is a length of the power sets. Okay, so the both command you can use any one. Okay, so the next one is a Cartesian product of the set. Okay, so here we have a two sets A and B. So A is equal to 1 comma 2 and B is equal to A comma B comma C. We need to identify the Cartesian product of these two sets. Okay, so this is a inbuilt command. It's available in the Python programming. So Cartesian product of A comma B for A in A for B in B. Okay, so just run this. Yeah. So this is a Cartesian product of the two sets 1 comma B, 1 comma A, 1 comma C, and 2 comma B, 2 comma A, 2 comma C. Okay. So this is a Cartesian product of the sets. Okay. So dear participants, is there any queries regarding the basic set operations? Okay. So I hope there is no queries regarding. Comma B. Yeah, this is a Cartesian product. Okay, so here A and B are the sets. Here this the output is the tuples. So this is a Cartesian product of A and B. Okay, so the output is the Cartesian product. That's why that provide the 1 comma B, 1 comma A, 1 comma C like that. Okay, so this is an ordered pair. So like that. Okay, is there any other queries? Okay, so I hope there is no queries regarding this basic set operations. So next we will say about relations and functions by using Python programming. Okay, here we have a, binary relations and we have a equivalence relations like that. We have several relations concepts. We have a symmetry and we have a, reflexive. We have a transitive like that concepts available in the mathematics and how to check relations by using the Python programming. Okay, so that is our motto of this particular commands. And here we have to check the binary relation of the student and as well as courses. Okay, so this is my sample data for identifying the binary relation of the subject and as well as the student. Okay, so here we have Alice. He is enrolled in Math 101, and here we have a Bob physics. He is enrolled in physics, and Charlie, he is enrolled in math, and Alice also enrolled in physics, and Bob is enrolled in chemistry. Okay, so this is my raw data. Okay, so we need to identify what is the relation between allies. Okay, so ally, what are all the courses? Choose allies. Okay, so this is a simple set of data. easily we can identify by the input. Okay, so always choose math and physics. Okay, so we need to check through the Python programming. Yeah, so course in which Alice is enrolled, math 101 and physics 201. Okay, so like that we can check the we can check the binary relations. Okay, so next we need to check the equivalence relation. Here we need to identify the sibling relationship. Alice is a sibling of Bob, and Bob is a sibling of Alice, and Charlie is sibling of David. Okay, so we need to check the sibling relation. So just run this. Alice and Bob is a sibling. Okay, so this is our query. Our Alice and
Sir,
Bob is a
screen is not
sibling. Yes.
visible.
Yeah, just wait, ma'am. I will check. Is it visible, ma'am?
Yes, sir. Thank you.
Okay. Thank you.
Yes,
Thank
sir.
you. Thank you for your input. Yeah. Thank you. Okay, so the next one is equivalence relation. We are this is our query. Our Alice and Bob is a sibling. Yeah, yes, Alice and Bob is a sibling from the input one. Okay, so like that we can check the equivalence relations. And this is a partial order relation. Okay, so we are providing the some partial order 1 comma 1, 1 comma 2, 2 comma 2, 2 comma 3, and 3 comma 3. So this is our input of the partial order. We need to check one is a less than one less than or equal to two. Okay, so just run this. Yes, is the one less than or equal to two? So true. This is our relation. Okay, so next we need to identify what is the square of a number. Okay, so we need to identify the square of pi square. Okay, so just we can run this. So by using relation concepts, we can check the relations as well. Okay, so this is a 25. Okay, so the next concept is a logic and proof techniques. We have a many proof techniques. For example, we have an induction method. We have a some other proof techniques. We'll check what are all the techniques available by using Python programming. Okay, so the next we will see the logic. Okay, so here I have produced the two logic. If p is equal to true and q is equal to false. Okay, so this is my logic. P is equal to true and q is equal to false. Okay, so just I need to check the logical operation, conjunction, disjunction, and negation. Okay, so then as well as implications. Okay, so I need to check these four logic operations. For example, conjunction, we can use p and q, and disjunction, we need to use p or q, negation not p, and implication not p or q. Okay, so this is a command to finding the logical operations. Okay, so then next we need to print all the inputs. Okay, so just yeah. So the conjunction p and q are false. Okay, so this is a p is true and q is false, though our result is a false. In disjunction, p or q, so p is true, q is false. The either one, any one is true, then the result is true. Okay, so this is our answer. Then negation. So negation, p is true. The negation of p is false. Then the implications. So implication, p implies q. So that is not p or q. So not p is false and q is also false, and we'll get the false. Okay, so like that we can approach the logics through the Python programming. Okay, so the next concept is define the predicates and as well as the variables. So like we need to identify the universal quantification and essential quantification for by using the logic values. Okay, so here I can produce the p is equal to lambda and x such that x is greater than or equal to 0. That is a positive integer predicate. And the q, so q is a even integer predicate. I have produced here x percentage of 2 is equal double equal to 0. Okay, so this is a even integer predicate. By using these two input, we need to identify given input is even or not. Okay, so just run this. Yeah, the universal quantification for every positive integer is true, and exponential quantification even integer is true. Okay, so but from the input, so these are true. Okay, so we want to identifying the first n positive integer. Okay, so the next concept is identifying. This is a mathematical induction method. So this is a example for proving the induction method. Okay, so this is a coding for proof techniques of induction method. So that sum of the first n positive integer is n into n plus 1 divided by 2. We need to prove result by using these comments. Okay, so first we need to define what is a n and these formulas. So that's why definition sum of n and written n into n plus 1 divided by 2. Okay, so definition proved by the induction method. For n is a range, we need to put the range and we need to provide other values. Okay, so here I can produce, we need to check the first 100 values. Is it true or not? Just run this mathematical then access Python programming for our religions. So the next concept, number theory is one of the familiar domain in mathematics. We'll explore this number theory in this Python programming. So in the number theory, we will see what is the congruence value and how to check the divisibility and how to check the prime number, prime factors. So like that concept, we will see through this coding. Okay. So is there any queries regarding the previous topics? Okay, so I hope there is no queries regarding the previous comments. Okay, so next one is the number theory. So checking divisibility, we need to check the divisibility of 15 and 3. Okay, so we need to check A is equal to 15 and B is equal to 3. Is divisible by A percentage of B equal to. Okay, so this provide the divisibility. Okay, so we need to checking if number is prime. Here definitely we need to provide the definitions for checking the prime values. Okay, so just run this. Okay, so 15 is divisible by 3. Yes, it is true. 15 is divisible by 3. So we can change the values as well. We need to put the 16. Yeah, so 16 is divisible by 3, it is a false. Okay, so then we need to check prime number, prime number. So this is a prime factor of the given input. So this is a basic syntax for identifying the prime number. Okay. So here I can put the 17. So 17 is a prime number. Suppose you can put the 18. So 18 is not a prime. 18 is not a prime number. So this is also false. Okay. Like that, we can approach the number theory through the Python programming. Okay. So the next one is calculate the GCD, greatest common divisor, and the LCM, least common multiple. Okay. So okay, so this is a basic command. So GCD underscore result. So this is a math.gcd. I have identified 24 comma 36. What is the GCD value? And we need to identify the LCM value 24 into 36. Okay, so just run this. The GCD of 24 and 36 is 12, and LCM of 12 and 36, 24 and 36 is 72. Okay, so like that, we can identify the any number of any values. We can change the values as well, like 54 and 554 and 326 as well. Okay, so just run this. Yeah. So GCD of 24, here we need to change these values 554, and we need to change 3236. Yeah. So GCD of 554 and 3236 is 2. Okay, so this is a GCD value of the given input, and we can change these uh, parameter values. Okay, so the next concept is modular addition. Modular addition is the one of the peculiar concept in number theory. So we need to use through the Python programming. Okay, so here I can fix a is equal to 5 and b is equal to 7. The modulus value is 10. Okay, so this is our basic input. A is equal to 5, b is equal to 7, and modulus equal to 10. Okay, so we need to identify the result of a plus b percentage of modulus. Okay, so then we can print these values. Okay, so just run this. Yeah, 5 plus 7, so mod 10, so the value is 2, and the next one is a modular multiplication. So here x is 3 and y is equal to 4, and modulus value is 7. Okay, so this is a syntax for identifying the multiplication of modulus. 3 into 4, the mod 7, so the result is 5. Okay, so like that, we can explore the modular addition and multiplication by using the Python programming. The next concept is inverse mod. Okay, so this is a n equal to 3 and n equal to 7. We need to identify the inverse of the mod inverse a comma n. So just run this. Yeah. So this is a modular inverse of 3 modulo 7 is 5. Okay. So like that, we can approach modulus by using Python programming. Okay. So the next concept is prime factorization method. So the prime factorization method, I have inputted the value is 120. The factors, prime factors, this is a identification of prime factors. Okay, so this is a basic syntax to identifying the prime factors. Factors equal to prime factors of number. So this is an inbuilt command. It is available in Python programming. So just I have used that code, and we can check. So this is a prime factor of 120, 2 comma 3 comma 5. We can change the values as well. 130 can change the values. Yeah. So this is a prime factor of so this huge value 2 comma 3 comma 5 617 727. Okay, so this is a prime factor of the particular given input. Okay, is there any queries regarding these basic number theory concepts by using Python programming?
No, sir.
Okay. Okay, so next we move on to graph theory, then we'll check some other concepts. So is there any queries regarding the previous session? Shall we move the next agenda? Okay, so the next we move on to the graph theory with Python programming. So graph theory is one of the domain in mathematics. It have so many researchers working in this particular domain. Okay, so here we need to use this package. So this package name is called the network X. So this is a installation process. So pip install network X. By using this command, we can install this package. So network X. Okay. So here we have a import network X. Okay. So here we are importing this. Just wait. Yeah. So, so this is a import of the network X. Just run this. And here we need to use initialize the graph. Okay, so G is equal to nx that nx is nothing but our network X package. Okay, so here we can abbreviate this nx. Okay, so nx means that network X package. Okay, so here we can create an empty graph. G is equal to nx dot graph. So this is a creation of an empty graph. So just run this. This will create the empty graph, and we can add the node. Okay, like we have added the node 1. Okay, so this is a command to adding the vertices, like z dot add node of 1. Okay, so just run this. Yeah, so this is our the vertex 1. Okay, so this is our vertex 1. This is an empty graph, and we are adding the one more vertices, like that vertices is labeled as 1. Okay, so the same similar concepts we can add the set of list of nodes as well. Okay, so here we can add the nodes from 2 comma 3 comma 4 comma 5. Here we can add 4 nodes in the certain list of elements. Okay, so just run this. Yeah, so here we can add the already we have a node 1. So in the node 1 we can add the some other nodes 2 3 4 5. Okay, so this is node 2, this is node 3, and this is node 4, and this is a node 5. Okay, so we need to add the edges between these vertices. Okay, so that is our next concept. G dot add edge. We need to add the edge between 1 comma 2. Okay, so this is 1 and this is 2. We need to add the edge between 1 and 2. Okay, so this is a command to adding the edges. G dot add edge 1 comma 2. Okay, so this is nothing but this is a output command. Nx dot draw network X of G is this command provide the output of the particular commands. So just run this. Yeah, so here we are adding the edge between 1 and 2. Okay, so next we need to add the list of edges. So G dot add edge from, we need to add the edge between 2 comma 3 and 3 comma 4, 4 comma 5, and as well as 5 comma 1. Okay, so just run this. Yeah, so this is our result graph. Okay, so we have a edge between, already we have 1 comma 2 edge, we have edge between 2 comma 3, and we have edge between 3 comma 4, and we have edge between 4 comma 5, and as well as 5 comma 1. Okay, so like that we can create a any graph by using Python programming. Okay, so the next concept, we need to change the vertices color, edge colors, like that. Okay, so that is our next concept. Is there any queries regarding this creation of a graph by using Python programming? Is it audible, ma'am?
Yes, sir.
Okay, thank you, thank you. So I hope there is no queries regarding the Python with graph theory, the creation of node and edges. So the next we move on to the nx dot draw network x. We need to change the color. The vertex color is a red and node size is 1000. Okay. So this is a here we have a vertex color is a blue. We need to change the vertex color as a red. Okay. So this is a syntax for changing the colors and the size of the nodes, vertex, and edges, like that. Just run this. Okay, so this is a color changed. Here we can change the node color as a red. Okay, so the next one is z dot number of nodes. Okay, we need to identify how many vertices available in this particular graph. Okay, so this is a general command, print z dot number of nodes in z. Okay, so just run this. We have here we have a 5 nodes, so we need to check what is a node. Yeah, so that we have a 5 nodes available in this given input. Okay, so then we need to check how many number of edges in this particular graph. So that is also 5. Okay, so then we need to identify what are all the nodes available in this particular graph. Okay, so just run this. We have a node labels 1, 2, 3, 4, 5. So this is a node labels available in this particular input. Okay, so then we need to check the print z dot edges. Okay, so here we have a edge between 1 comma 2 and 2 comma 3, 3 comma 4, 4 comma 5, and as well as 5 comma 1. We need to check. Yeah, so here we have a 1 comma 2, 1 comma 5, 2 comma 3, 3 comma 4, and as well as 4 comma 5. So like that we have an edges. Okay, so the next concepts, we need to identify the degree of particular vertex. Okay, so we need to identify the degree of the vertex 4. Okay, so this the degree of vertex 4 is 2. We need to check the degree of vertex. So just, yeah, the degree of the vertex 4 is 2. Okay, so we can add the one more edges, like that. Just copy that. Add info. Yeah, yeah. So this is our input. Now we need to check degree. Yeah, the degree of 4 is 3. Okay, so the degree is nothing but the particular vertex is adjacent to some other vertex. Okay, so here we have a 4 is adjacent to 3, 4 is adjacent to 1, and 4 is adjacent to 5. So the degree of 4 is 3. So that is our result. Okay, so next we will create some other graphs. So like we need to create the H graph. So this is an empty graph, and print z dot degrees, and this concepts already we have seen. So print g as edge between 1 comma 7. Okay, so we need to check, is there edge between 1 comma 7. So it is false. There is no vertices available in this particular input 7. Okay, so here we have a up to 5 vertices. It's not a 7. So just we need to check. Yeah, it is a false. So G has edge between 1 comma 7 is a false. Yeah, yes. Is there any queries?
Dear participants, use your mic, please.
Okay, thank you. And we need next we will see about manipulation of vertices and edges. Okay, so just we can remove the edges, we can remove the vertices, we can concepts. Okay, so the next concept is we can create some other graph. H is equal to nx dot graph. So this is in creation of an empty graph, and we have a edge list 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, and as well as 1 comma 6. Okay, so then we need to check h dot add edges from the edge list. Okay, so this is our new graph. So like that, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 2, and as well as 1 comma 6. Okay, so here we need to remove the edge. We need to remove the node 4. This is our node 4. We need to remove this node. Okay, so this is a general command, h dot remove node. Okay, so just run this. Yeah, so we need to draw this. Yeah, the node 4 is removed. Okay, so here we have a only node 1, 2, 3, 5, and 6. Node 4 is deleted. Okay, so the next one is deletion of edge. We need to remove the edge between 1 comma 5. So this is a 1 and this is a 5. Okay, we need to remove the edge between 1 and 5. Okay, so just yeah, so this is our resultant graph. Okay, we are removed edge between 1 comma 5. So this is a resultant graph. Okay, so the next one is we need to create the path graph. Okay, so this is a one type of graph in graph theory. So path. Okay, so we need to create path graph with 100 vertices. Okay, we need to create path graph with 10 vertices. Okay, so just run this. Yeah, so this is a path graph of 10 vertices, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is a path graph of 10 vertices. You can create any number of vertices, for example, 100 as well. So this is a path of the 100 vertices. Okay, you can create any number of vertices with appropriate comments. Okay, so the next we need to create a cycle graph with 50 vertices. So we need to first create the cycle graph with 5 vertices. Yeah, so this is a cycle graph of 5 vertices. So this is a this is an inbuilt command. So the edge label vertex labels are automatically assigned by Python. If you are created, if you are using the your own coding, so we can label manual, but we can here we are using the inbuilt command, so that's why this automatically labeled by Python programs. Okay, so this is a output of the cycle graph. Okay, so we can create any number of cycles. So this is a cycle graph with 25 vertices, and we can create complete graph. So complete graph is nothing but so every vertex is directly connected to some other vertex, or every vertex, if there is a vertex, is adjacent to some other vertex. So we are creating the complete graph with 5 vertices. Yeah, so this is a complete graph of 5 vertices. Okay, so we can create any number of vertex as well. Okay, so for example, if you want to create a 100 complete graph of um, 50 vertex, that is also possible. Yeah. So this is a complete graph of 50 vertices for the given input. Okay, so like that we can create any number of graphs. So these are all the basic fundamental types of graphs. Okay, so the next one is we can create the bipartite graph. So this is one of the concept. It is available in the graph theory. In the bipartite graph, we have a two sets. We have a two-partite set. So by using that partite set, we will create the graph. Okay, so this is a comment to plot the bipartite graph. So first we need to create an empty graph, and z naught. This is a vertex one. This is a vertex two, and this is a edge between the vertex one and two. Okay, so just run this. Yeah. So this is a bipartite graph with the two sets. Okay, in set one contain 1, 2, 3, 4. The set two contain the 5, 6, 7 vertex. Okay, so this is a edge between the vertex set of 1 and vertex set of 2. Okay, so like that we can manipulate the bipartite graph. This is already we have seen the complete graph with 5 vertices. Yeah, this is a complete graph with 5 vertices. Then the next concept is there any queries regarding the concepts? Dear participants, is there any queries?
No, sir.
Okay, thank you. Okay, so next we need to check the subgraph. Okay, so like this is our graph. We need to collect the subgraph in K5. Okay, so in this K5, we need to plot the subgraph K3. So K3 is equal to K5 dot subgraph. We need to access three vertex like 1, 2, and 0. Okay, so this is our subgraph of this particular graph. So this is our output. Yeah, 0, 1, 2. So this is our subgraph from this main graph. Okay, so the next one is we can create some other graph. So this is our new graph. So in this new graph, we can add the edges and the vertex as well. Okay, so like that we can create a vertex. So the next one is union of graph. So union is nothing but we can join the two graphs. Okay, so like this is an NX union of. So this is our graph A and this is our graph B. We need to add these two graphs. Okay, so just run this. I think there is an error between this. Yeah, there is no common vertex between these two graphs. So that's why we have an error. And the next concept is z dot add edge from. So this is our new vertex. And this is our, we need to compose these two graphs. So like that. Okay, so this is a composition of the B and C. Okay, so the next one is product graphs. We have a certain product. It is available in the Python programming. Okay, so as well as graph theory, we have a Cartesian product, tensor product. We have a lexicographic product, and we have a several products. It is available in graph theory. We can do the coding as well in Python programming. Okay, so first we need to check the Cartesian product of these two graphs. So K3 is the complete graph with three vertices. K2 is complete graph with the two vertices. We need to check the Cartesian product of these two graphs. Okay, so just run this. Yeah. So this is a Cartesian product of these two graphs. Okay, so here we have a vertex set of 0, 1, 0, 0, 2 comma 0, 1, 2 comma 1, 1 comma 1, and as well as 1 comma 0. So by using these comments, we can check the Cartesian product of these two graphs. Okay. So the next one is the tensor product of graphs. Okay, so we need to check the tensor product of K3 and K5. You just run this. Yeah. This is the tensor product of the graphs. Okay, so the next concept is directed or undirected graph. Okay, so if the and all of you familiar with this graph theory, so this is a directed graph. So the directed graph contains the directions between the vertices. Okay, so like that we can create the direction as well. Okay, so here we have 1 comma 1. This is a direction, and these are all the bi-directional graphs. So that's why we have this direction. Okay, so in graph theory we have a several named graphs like Peterson graph. We have some other named graphs. We'll check that. So this is a Peterson graph with so this is a Peterson graph, and we have a complement of this Peterson graph. We'll check the complement of this Peterson graph. This is a complement of the Peterson graph. Okay. So the next one is we can create vertex or labeling. So this is a labeling concept. By using the labeling, we can change the vertex labeling. For example, vertex 0 is labeled as 10, the vertex 1 is labeled as 11, and the vertex 2 is labeled as 12, and the vertex 3 is labeled as 13, and vertex 4 is labeled as 14. Okay, like that we can label the graph. The labeling is one of the subdomain in graph theory. By using the Python programming, we can access the labeling as well. Okay, so here we have several types of labeling. Okay, so these videos is available in this in our YouTube channel. You can see that this is already we have completed 2 days workshop. So Python programming with the graph theory. So you can access that materials as well. It is available in YouTube channel. Okay, so these are all the some other basic comments. Okay, is there any queries regarding graph theory with Python programming? Okay, so I hope there is no doubts regarding this session. The next we move on to combinatorics. So the next agenda we move on to the combinatorics, and we have and the next followed by cryptography and followed by lattices theory, and we have several agendas. Okay, so okay, so we move on to the combinatorics. So combinatorics, we have a permutation and the combinations is available in this particular domain. We need to check the what are all the permutations available, what are all the combinations are available, and we have a pig and cold principles like that. We have several concepts available in this particular domain. We'll see the minimal level of topics with the combinatorics subject. Okay, so here we have used the factorial of package from math. So this is a we are using the math package here. Okay, so here we can check the permutation of n equal to 5 and k is equal to 2. Okay, so this is our basic input, n equal to 5 and k equal to 2. This is a permutation factorial of double slash factorial n minus k. Okay, so this is our comments to identifying the permutations. Okay, so just run this. Yeah, the permutation of 5 is taken 2 at a time which is equal to 20. Okay, so if you have a n 5 n is equal to 5, k is equal to 2. So there is a possibility to taken the 20 times. Okay, so the next one is a combination. So the combination is n equal to 5 and k is equal to 3. This is our basic input. So this is our formula, combinations, which is equal to n factorial by k factorial into n minus k factorial. Okay, so this is our basic formula. Just I have inputted the formula in the directed manner. So this is our output. Combination of 5 objects taken at 3 times is 10. Okay, so this is our answers. Is it clear? Is there any queries regarding this? Okay. So the next we will say about binomial expansion. So this is already we have seen in this previous session itself, binomial expansion. So this is a binomial expansion. We need to provide the symbols x comma y is equal to symbols of x comma y. So this is a binomial expansion. You need to check the binomial expansion of 4. Okay, so this is a n is equal to 4. So x plus 5 the whole power 4. Okay, so this is our output. X power 4, 4x cubed by 6x squared y squared, 4xy cube, and y power 4. Okay, so this is our input. Okay, so the next one is providing that group of 101 peoples, at least 2 peoples have the same birthday. Okay, so this is our problem. So this is our example. Okay, so just we can check. For example, 101 people in this meeting. So at least 2 people have the same birthday. Okay, so this is we need to check. Here we can change the variables as well. Okay, so here we have a 250. The number of birthdays 365. We need, this is a general command. So maximum different birthdays n birthday minus n people plus 1. Okay, so this is our condition. So we need to check this. Yeah, so at least 2 people in the group have a same birthday. We can change the values as well. For example, we can check around 450 people in the gathering. So how many people have a same birthday? So just check that. Yeah. So this is at least 2 people in the group have a same birthday. Okay. So we can change the values as well around 2000. Okay, so this is a general command. And next we move on to generating functions. So okay, so next we have factorial series. We need to check the ordinary generating function, and this is an ordinary generating function sequence. Okay, so define the variable. So this is already we have seen in yesterday session itself. So x is equal to symbols, and here we have a define the generating ordinary generating functions, the symbolic function. So like a is equal to function of a into x. Okay, so this is a basic definition, and we need to check the sequence is equal to factorial of n for n in the range of 6. Okay, so we need to generate this 6 sequence like this. Okay, so just run this. Yeah, so this is a ordinary generating function for the sequence 120 x power 5, 24 x power 4. So like that we can generate the functions. And the next concept is the next one is also the generating function. So here's the next concepts. We need to check the combinatorics of the given inputs. So for example, generated the balance complete incomplete block designs. Okay, so here these are all the arguments for the following comments. Okay, so we need to identify what are all the blocks available in this particular area. Okay, so this is our
The screen is
input.
not hiding.
Just wait, sir. We'll check. Yeah, sorry for the inconvenience. Is it visible now?
Sir,
Yeah, thank you. Thank you for input. Okay, so this is a input regarding this block. Okay, so here we can generate uh, balanced incomplete block design. Okay, so this is our output. So like that, the block 1 contains 0, 1, 2, the block 2 0, 1, 3, the block 3. So like that we can get the block elements. Okay, so the next concept is Latin square. So Latin square is one of the subdomain of discrete mathematics. Okay, so the Latin square is an n cross n array filled with n distinct symbols or elements. Okay, so that is called as a Latin square. Okay, so the Latin square applications in the various fields, like we have a Sudoku puzzles and we have arrangements of objects like that. We can use the Latin squares. Okay, so these are the basic definitions is available in this Latin square. Okay, so this is a general command to generate the Latin squares. Okay, so this is a definition for generate the Latin square. So generate Latin square is equal to Latin square of 0 into n for the range n. Okay, so here I can fix the ranges, range 1 comma n plus 1. Okay, so this is a Latin square row by row. Okay, like we can fix the first row and we can assign the second row as well as third row like that. Okay, so this is a printing of the Latin squares. Okay, so this is our input. This is our output for the given input. For example, this Latin square is 1 comma 4, 3 comma 2, 2 comma 3, 4 comma 1, 2 comma 1, 3 comma 4, 1 comma 4, 3 comma 2. Okay, so this is a Latin square of the given input. So for example, if we can change the values as well. The Latin square of order 6 can run this. Yeah, so this is a Latin square of an order 6. Okay, so like that we can generate any order of the Latin squares. Okay, so we can create the Latin square of 20 as well. Yeah, so this is a Latin square of 20. Okay, so the same similar examples in the with another one. So is there any queries regarding this Latin square and basic number theory concepts? Okay, so I hope there is no queries regarding this concept. Okay, so next one is cryptography. So cryptography, we are using the data science as well for hiding the data. Okay, so we'll see how to mathematics implemented in the Python programming by these concepts. Okay, so here we can use the bit array for coding purpose. Okay, so this is a package name, bit array. We need to arrange the bit array concepts in this program. Okay, so here we have encoded the humming data. So this is a r equal to 0, 2 in 2 power r length. Here we can fix the length 2 power r plus r plus 1. Okay, so this is a basic definition, and we need to create the list to store the encoded bits. Okay, so this is a encoding concepts, and we need to initialize the data. For example, initialization data is 0, and encoded I encoded data is 0. So this is a fill in the encoded data with placeholder for parity of bits. Okay, so like that we can encode it, and we need to do the decoded as well. Okay, so like that, this is a general command. We can use this command to identifying the cryptographics values. Okay, so this is an example for usage. So just we can run this. Yeah, so the encoded data is 11101010. So this received data with the errors is so this is our error data. Okay, so the final decoded data is this 11101010. Okay, so this is our data. Okay, so previously we inputted this one, and we will get output as a 11101010. Like that, we can encode and decode the data by using the Python programming. Okay, so the same similar commands, it is for the next example, and we move on to the representation of the next one is a vector representation and the basic operations. So the vector analysis concepts. Okay, so here we have several applications by the vector analysis method. Okay, so we can find the gradient, the curl, and we'll do the multiplication of vectors, addition of vectors. We can find orthogonality. So the many concepts we can convert it into Python programming. Okay, so here we can use the numpy is a package, numpy is a np. Here we can fix the vector. So our first vector is np.array 3, 4. This is my second vector. Vector 2 is equal to 1, -2. Okay, so this is a initializing the vectors. So here we can put the two vectors, vector 1 and vector 2. So we need to do the vector addition. So the result of addition is equal to, we can add the vector 1 and plus vector 2. Yes, this is our input. So if you add these two vectors, the result is 3, 4. Okay, so this is our result. Vector 1 plus vector 2 is equal to 3, 4. And so the vector subtraction. So we can subtract these two vectors, vector 1 minus vector 2. So this is our result. So 1, -2. Okay, so then we have a vector multiplication. So vector multiplication, scalar 1 into vector 1. So scalar 1 and vector 1. Here we can assign the scalar value is 2. Okay, so this is a vector multiplication. So 6, 8. Is it clear? Is there any queries regarding the vector addition, multiplication, and subtraction? Is the screen is visible?
Yes.
Okay, ma'am. Thank you, ma'am. Okay, so I hope there is no queries regarding the vector addition, subtraction, and multiplication. Next, we will check the dot product and as well as cross product of the vectors. here we can assign the two vectors, vector 1 and as well as vector vector dot product. So this is a command for identifying the vector dot product. So this is my vector 1 and this is my vector 2. So vector 1 is a 3 comma 4 and vector 2 is a 1 comma minus 2. So here we can do the dot product. So this is an inbuilt function. It is available in the Python programming. Okay, so this is the result. Yeah, the vector 1 is a 3 comma 4. The vector 2 is 1 comma minus 2. The dot product of these two vectors is minus 5. So the next concept is a cross product of these two vectors. Here we have a 3 vector ijk. So this is a 3D. So for example, vector 1 np dot array, which is equal to 1 comma 0 comma 0, and vector 2 we have a 0 comma 1 comma 0. Okay, so we need to do the cross product of these two vectors. It will produce the result like this here. Yeah, this is a cross product of these two vectors. So vector 1 is 1 0 0 to 0 1 0, and the cross product of these vector is 0 0 1. Okay, so the next we can check the vector magnitude and we will check the normalization of the vectors. Okay, so this is a vector np dot array, which is equal to 3 comma 4. This is our vector. So magnitude of the vector is we need to assign this is a magnitude, and we need to check the normalization of these vectors. Okay, so this is an output. Yeah, vector is equal to 3 comma 4. The vector magnitude is a 5, and the normalized vector is equal to 0.6 to 0.8. So this is a normalization of the vectors. Okay, so the next concept, we need to check the gradient and as well as curl. Okay, so this is a basic command to identifying the gradient value. Okay, so here we can check, define the scalar field of a function. So here we can define the scalar field is equal to x comma y. So this is a written function, x squared plus y squared. Okay, so this is a definition of the point in 2D space. X is equal to 2 and y is equal to 3. Okay, so just run this. This is a gradient of 4 comma 6. Okay, so this is a gradient value, and we can check the curl as well by using the same similar concepts. Okay, so then so this is a divergent at 2 comma 3 is 17 17 comma 17. Okay, so this is a divergent value of these two vectors, and we can check curl as well. This is a curl. So curl at 2 comma 3 is 17 comma minus 17. So this is our output. Okay, so is there any queries regarding these vectors analysis? So the last command is we need to check the orthogonal or not. These two vectors are orthogonal or not. Okay, so yes, the vectors are orthogonal. Okay, suppose we can change the values as 1. So we need to check this is orthogonal or not. This is not an orthogonal. Is there any queries regarding this basic vector analysis concepts?
No, sir.
Yeah, yes. Okay, so next we move on to the fuzzy sets. So this is a important aspects. I'll see the many concepts in the fuzzy sets. Okay, here we have used the package scikit hyphen fuzzy. Okay, so this is a new package for using this workshop. So scikit hyphen fuzzy. Okay, so this is a command to install this particular package for your coding purpose. Okay, so then we need to import these packages for our program. So import numpy. Already we have installed numpy, so that's why we can import here. Already we have. So this is installed by sk fuzzy as a fuzz. Okay, so this is another one package, and we need to introduce the matplot pyplot lib. Okay, so these three packages useful to do the fuzzy operations. Okay, so the next one is we need to change, we need to create a universe of discourse. Okay, so this is a x is equal to np dot range 0 comma 11 comma 1. Okay, so this is a range value of the fuzzy, and we can define the fuzzy sets using the membership functions. So okay, so this is a membership function. So I can define the membership values low equal to first dot trim f. So these are all the range of the membership function, and the membership function in high value. So this is a membership high values 5 comma 10 comma 10. Okay, so we need to plot the membership functions of these values. Okay, so this is a basic comments the perform the fuzzy set operations, like intersection of these two fuzzy sets, and as well as union of these two fuzzy sets. Okay, so this is a basic comments for intersection and as well as union. Yeah. Yeah, this is our output fuzzy set for the temperature. Okay, so this is a membership degree of this particular set. Okay, so already we have list the membership in the low and high in 0.60. Okay, so this is a membership degree. Okay, so this one and this one. This is the blue indicates the lower level membership function, and red indicates the higher level membership degree. Okay, so like that. So this is a curve of high, and this is a curve of low. So this is a union of these two fuzzy sets. Okay, so this is a union value, the membership degree. So this is a union values of these two. Is there any queries regarding these concepts, the membership function and as well as union and intersection of fuzzy sets?
No, sir.
Okay, thank you. Okay, so the next concept which indicates the temperature of the room temperature by using, this is one of the problem to identify by using the fuzzy with the Python programming. Okay, so here we can define the universe of discourse for the temperature in Celsius. Okay, so the normal temperature in the room is 0, 101, comma 1. Okay, so this is a universe of discourse, and we can create the membership function. So this is a, here we have a triangular membership function. So like we need to create the temperature cold. So this is a range value of the cold, and this is a moderate value 15 to 85. Okay, this is a moderate value. If it is a hot, we can fix this membership function. Okay, so this is called the triangular membership function. Okay, so we need to visualize this membership function by using this plotting method. Okay, so this is a plot membership function. Okay, so this is a output of this. Okay, so here the blue line indicates the cold, and Green line indicates the moderate and red line indicates the hot. So this is a output. So next we need to check the membership degree values from the given input. Okay, so that is the next concept in fuzzy. We need to check the membership functions. Yeah, the degree of membership for the 40 degrees 0.71. Okay, so the 40 degrees 0.71 like that. So here, so the degree 40 is 0.71. Okay, so like that, we can check the membership functions from the given input functions. And you can change the membership values in the Python coding as well. Okay, so this is some other outputs from the changing the triangular membership function. Okay, so this is a triangular membership function. Like we need to fix a is equal to 2, b is equal to 5, and c is equal to 8. So this is our triangular membership, and we can fix the membership functions values like this. So this is a membership function values. We can assign this. Then we can plot this diagram. Okay, so like that we can plot this. And the next concept, trapezoidal membership function. So already we have completed the triangular membership function. The next concept is trapezoidal membership function. It is one of the membership function in fuzzy. So yes, we can access that. Here, these are all the membership function: a equal to 2, b equal to 4, c is equal to 7, and as well as d is equal to 9. So this is a membership function declaration: x less than a less than or equal to x, and x less than b. So these are all the membership functions indications. Then we can visualize the graph. So this is a trapezoidal membership function. And as well as we can check the Gaussian membership as well. Okay, so this is a Gaussian membership coding. So here we can fix the mu and sigma values like that. So this is a mu value is a 5 and sigma value is a 2. This is a standard deviation. So mu is nothing but the mean. Okay, so like that we can create. This is a declaration of the Gaussian membership function. Okay, so np dot exponential of x minus mu divided x minus mu whole square by 2 sigma square. Okay, so like that we can create the Gaussian membership. Okay, so this is called the Gaussian membership function. Okay, so the next one is the support of a fuzzy set. So this is one of the concept. It is available in the fuzzy support. Okay, so here we need to check the membership functions degrees. Okay, so based on the membership functions, we can create that support functions. Okay, so this is a peak height 180, the half width is equal to 10. So these are all the membership functions of these program. Okay, so this is a membership declaration and this is an output. Yeah, so this is a membership function with the tall people. So this is a, here we have a tall people. Fuzzy set includes heights from 171 centimeter to 181 centimeter. Okay, so this is a tallest people. So this peak indicates the tallest people. So the value is 171 to 189. So these peoples are the tallest in the given input. Okay, so is there any queries regarding the fuzzy set, fuzzy indications, and fuzzy membership functions? I hope there is no queries regarding this particular concepts. We move on to the next agenda. So that is a fuzzy set operations. Okay. So fuzzy set operations, we can create. Yeah, already we have seen union, intersection, and as well as some other concepts. So this is a union or operation. Okay. So this is a age range. So this is a membership universe discourse age range 0 to 101 and height range 100 to 211 and this is a membership functions tall membership is 170 to 210 and young membership is 18 to 40 the visualize the membership functions like 12,4 the figure size. Okay, so this is a plotting comment. Yeah, so this is our output. Okay, so membership function of tall people. So the membership function of the tall people is like this. So around 168, around 168 to around 2 to 220 like that. Okay, so this is a young people. So young people is lies between 18 to 40. Okay, so this is a membership function of an young people, and this is a union of the tall people and young people. Okay, so this is the union value of tall and young people. Okay, so the next concept is membership function with the intersection. Okay, so the same command. So this is an output. So just wait, this will be loading. So this is the intersection of tall people and as well as young people. Okay, so there is no common difference between these two. So that's why this is a straight line. There is no intersection of these two sets. And the next concept. So the same, like the common range between both membership functions. Okay, so this is an output. Yeah, still it's loading, just right. Yeah. So this is a membership function of the tall people and young people. So this is a difference of tall and young people. So this is a union. So this is a difference of tall and young people. The difference between the set A and as well as set B. And this is a complement of the set. In the fuzzy, we have this is a complement of a fuzzy set. Okay, so this is a membership function of the tall people. So this is a complement of the tall people. Okay, so these are all the concepts. It is available in the fuzzy. So is there any queries regarding this? Okay, so I hope there is no queries regarding this. Okay, so next concept we need to check. Okay, so the next one is dilated. So this is one of the concept. It is available in the fuzzy. Okay, this is a dilated graph. Okay, so the membership function for the tall people. This is a dilated values so 1.5. Okay, so if you fix the alpha is equal to 1.5, so this is a dilated. Okay, so dilated is nothing but that is another one name of scaling the membership functions. Okay, so this is an output. Okay, so the next one is fuzzy logic. So we are using the fuzzy logic to identifying the temperature, and we need to check the uh, populations as well. Okay, so this is a next concept. So we need to use the same similar packages Here we can use the linguistic variable and their ranges. Here we can fix the temperature. Temperature values 101 to 101 and fix the fan speed. So fan speed is fixed 1 to 101. We can fix the fuzzy membership functions like this. So temperature cold 0 to 40, temperature warm 30 to 70, and the temperature hot we can fix 60 to 100. Okay, so these are all the membership functions, and we can fix the define the fan speed itself for the membership function of fan speed. So fan speed low, we can fix these values. Fan speed medium, we can fix these membership range, and fan speed is high, we can fix these membership range. Okay, so if you fix the, we can assign the rules, certain rules for the logic. For example, rule one. So we need to, if the temperature is cold, the fan speed is low. So this is a first rule. If the temperature is cold, the fan should be low. And the second rule, temperature is warm, the fan speed is medium. And now rule three, so temperature is hot, the fan speed is high. Okay, so like that we can fix the rules. And sorry for the interruption. Okay, so the next one is we need to assign the control system. So this is a control system for our program. So fan speed control, which is equal to control of control system. Rule one, it satisfies these rules: rule one, rule two, and rule three as well. So this is a fan speed simulation. So for example, control system, this is a fan control. We need to include this fan speed control for creating the simulation. Okay, so this is a provide input temperature values. So this is suppose if the room temperature is 65, so these simulator will assign some conditions for the fan. Okay, so like that we can run this. Yeah, so this is a output for this simulation. Okay, suppose if you provide the fans room temperature is 65, the fan speed will be assigned 56.73. So this will be the value. Okay, so this is our room temperature. It's black line indicate as a room temperature. So here the blue line indicates the cold, and orange line indicates the warm, and green line indicates the hot. Okay, if the fan speed is 65, so like that we can change the values. Okay, so this is a fan speed. So it's look like a simulator. Okay, we can assign that fan speed is 22.02. So this is our line. Fan speed is 22.02. This black line indicates the fan speed is 22.02. So it's predict the values. Its room temperature is low. Okay, so the next one is the fuzzy logic inference. Okay, so by using these methods, we can do the fuzzy logic inference. Okay, so this is a temperature control dot Anderson's np dot arrange 0,101 humidity and like that. Okay, so this is a lower level. Okay, so just run this. Yeah, so this is a indication. Fan speed is 79.33. So this is an interference value. So it's took the room temperature is 5. Okay, so is there any queries regarding this fuzzy interference and fuzzy logic? Dear participants, this is a advanced level of Python programming. We need to fix the variables and values itself. Okay, so that's why we can omit this. Okay, so we'll share this notebook. You can try in your system. Is there any queries? Shall we move the next topic? Okay, so I think there is no time for some other topics. We'll conclude with the real analysis itself. Okay, so this is the last topic for our workshop. So suppose if you have in future sessions, we will see some other topics. Okay, so for example, we have a statistics, fluid dynamics, and we have a topological concepts like that. In future workshop, we will see the particular concepts. Okay, so we'll conclude with the real analysis concepts. Okay, so and in the real analysis point of view, we need to check the convergent of the sequence, convergent, divergent, limit values, like that. Okay, so the basic concepts we'll see in today's session. Okay, so this is an example of the convergent sequence. For example, 1 by n converges to 0. Okay, so this is a function. So here we have 1 by n is greater than or equal to 0.01. We can fix this. This is a condition. Okay, so just run this. Yeah. So this is a value of the limit 1 by n is n approaches to infinity. So 0.0009. It continue. That's why this is a convergent sequence. Okay, so the next one is we need to check the limit of the limit sum of the sequence and limit product of the sequence, and as well as limit ratio of the sequence. Okay, so this is a command. Okay, so here we can fix the an. So an is equal to 1 by n for n is the range from 1 to 6. Okay, so this is a an. So this is a range of bn. Bn is the range is from 1 to 6. We need to identify the sum limit between an to bn, an plus bn. So this is an output 3.425. The limit sum of the sequence is 3.425. Okay, so the next one, so the same similar concept, we need to check the product limit. The limit of the product sequence is 34.25. This is a product limit. And the next one is a ratio of the ratio product limit of the ratios. Okay, so the limit of the ratio is 0.15 22222. Okay, so this is a coding for identifying the limit of the sum, limit of the product, and limit of the ratio of the sequence. Okay, so the next concept is monotone sequence. So the monotonic sequence is already we have this is familiar with all of them. So suddenly decreasing or suddenly increasing or non-increasing or non-decreasing concepts. Okay, so here we can use the is non-increasing. We can provide some condition. Okay, so this is our condition. All 1 by n is greater than or equal to 1 divided by n plus 1 for the ranges of 1 to 10. Okay, so this is a non-increasing and this is a non-decreasing sequence. So just run this. Yeah, is the sequence 1 by n is non-increasing? Yes, it is a true. This condition is true, and this condition is also true for this a non-decreasing sequence. We can change the ranges. If you change the ranges, we can check the code. Yeah, so here also this is a true. Okay, so the next one is a convergent and divergent of a series. Okay, so the convergent of the series and divergent of the series. So this is a basic command. Okay, so here we need to check the arrange the ranges 1 to 1001. So the series 1 by n square, 1 by n square. This is our series. So just run this. Yeah. So it's convergent at 1.6439. Okay, so this is a convergent rate of this series. And we have several tests to identify the convergent and as well as divergent. The first test is a comparison test. Comparison test, it is useful to identifying the divergent or convergent. Okay, so this is our series 1 by n square. This is a series B 1 by n. We can check this condition. Yeah. So the sum of the series 1 by n squared is convergent into 1.64, and the sum of the series 1 by n is convergent to 7.4854. Like this, we can check the convergent and divergent as well. Okay, so the next concept is the point-wise convergent. This is a coding for identifying the point-wise convergent values. Okay, so this is a general command to identifying the point-wise command. So just, yeah. So this is a point-wise convergency of this given equation. So our given equation is 1 by n into x power n. 1 by n into x power n. So this is our function, and this is the values of this. Okay, so this is a point-wise convergence. Okay, so this is a if n is equal to 1, so this convergent level is medium, and if n is equal to 2, so this is a range, and if n is equal to 3, like that, if n is equal to 4 and n is equal to 5. Okay, so like that we can check some other values as well. Okay, so we have a many codings for this particular comments. We need to check the Weierstrass M test as well. Okay, so here we can put the function values 1 by 2 whole power n, 1 by 2 whole power n. So this is a Weierstrass M test. If n equal to 1, mn value is 0.500. So this blue line indicates the Weierstrass test with the variable of 1, the first step. And the second line, so this is orange line. If n is equal to 2, mn value is 0.250, and we can increase these values. Like if it is a green, this is a 3, mn value is 0.125 from the Weierstrass M test. So this is our function 1 by 2 whole power n into sine 2 power n, sine squared n. So like that. So this is our function values. And we have a power series representation as well. So this is a power series representation concepts. Okay, so this is a e power x from the Taylor series. Okay, so last but not least, we can conclude with intermediate value theorem. Intermediate value theorem. Okay, so this is a coding for identifying the intermediate value theorem. So all of you familiar with this intermediate value theorem? We need to we have a function x cube minus 6x squared plus 11x minus 6. Okay, so this is our function, and the interval between 1 comma 4, and we have to compute the function f of a comma f of b. Okay, so this is our intermediate value theorem, an example. So this is our function. This is the endpoints f of a comma f of b. This is k is equal to 0. So this is an intermediate value theorem for this particular concepts. So the next concept is a double integral. So this is a double integral value.
Dear participants, if you have any queries, if you have any queries, we will continue, or otherwise we will close the session. Please raise your hands if you have a questions. Okay, thank you so much for your patience listening.
Yeah, dear participants, the feedback link is available in the chat box. Kindly fill that feedback link for the certification process. I will send the certificate within 2 days with the recording link and as well as handouts. If there is a query, so kindly rectify. We will try to rectify the particular queries. Yeah, sure, sir. Seema Mera. We are planning for conducting the specified workshop for fuzzy graph theory using Python programming. So we are planning. So maybe the next month we'll execute that part. And some other queries regarding the queuing theory and operation research. Yes, sir. Today there is no time to see that particular concepts. So the next workshop we will complete this operation research and as well as queuing theory. So that is a huge area in this Python programming. So that is very helpful as well. We will see in the future sessions. Yeah, thank you for your feedback, Vishwa Prakash. I will act accordingly. Fuzzy graph theory with Python. Yes, we are planning for the next month. Fuzzy graph theory with Python programming. So any reference book? As of now, there is no reference book, sir. We are uh, we are writing the book for Python programming with graph theory. It is already completed. That is in publication point of that is in publishing. Uh, we are waiting for the publication. And as of now, there is no book for Python programming with mathematics. We are compiling that book. So it's almost 80% work is completed. Within 2 or 3 months, we will publish the book Python programming with mathematics. And advanced ODE using Python. Sure, ma'am. We'll check how we can solve the summation and product, the same equation, sir.
Sir, is there any basic book for Python, sir, for understanding?
Ma'am, basic Python book is available in this market, ma'am. But Python programming with mathematics, there is no book as of now. We are compiling that
Do you
book
have any?
with. Ma'am, your voice is not clear.
Sir, Lectures Python is a good one. Right, sir?
Hello.
Hello, sir. If
Is
you
it
have any
audible?
materials, do you have any materials with you, sir? Hello?
Yes, sir. You are audible.
Ma'am, we have a normal Python programming. We have several materials. It is available in the market. But
Okay, sir.
Python programming with mathematics, I think in my yes. Okay, ma'am.
सर एस्केलन लाइब्रेरी के बारे में थोड़ा डिटेल्स में नहीं, मतलब और एक वर्कशॉप में अगर पता चलता तो अच्छा होता सर।
Sir, I don't know Hindi. Sorry for your inconvenience. Kindly ask in English or put it in the chat box. I will explain.
Good evening, sir.
Yeah, sure. Dhanaraksha ma'am, we will share. Yeah, yes, ma'am.
Sir, am I
Good evening,
audible?
ma'am.
Sir, I'm Suganya.
Yeah, yes, ma'am.
Sir, is there any possible to do the Python programming for differential equations?
Yeah,
Like,
yes, ma'am. It is possible.
is
It
okay,
is possible, ma'am. It is possible. In
okay,
future session, we will cover that particular topics.
okay, sir. Thank you, sir.
So as of now, we are covered the basic differentiation process only. So if we conducted the Python programming for differential equation, we will cover many topics in the particular area.
Okay, just how to get degrees, orders. It is simple calculations. Can we do, no, sir?
Yeah, that is an yesterday we have seen that concepts now.
Okay, okay,
Okay.
okay. Thank you.
Okay. Dear participants, I hope there is no queries regarding this program. And thank you for everyone, every participants for your reasonable listening. And I thank advisor of Indian Mathematics Professors Association and board members for giving me this great opportunities to interact the uh, present and future mathematicians, the Indian Mathematics Professors Association. And I also thank Infinity Research and Development Institute members and as well as board members for providing me this great opportunity. Thank you for all. We'll see in the future sessions. Thank you.
Thank you, sir.